All right. Hello there. My name is Joe Dragoni, Junior in BAME, and this will be my session 2 assignment, an analyzing time value of money of a certain financial decision. So, our decision is that we're a financial advisor helping a client plan for retirement. The client just graduated from college and is 22 years old, and his income is $65,000 per year. He wants to retire at age 65 and wants to save 30% of his income at every year end. So our inflation will be 2% per year. Our interest rate will be 5% per year for the next 43 years from 22 to 65. And his salary will increase by 3% per year. And as the advisor, we are suggesting him to invest 60% of his savings in stocks, 40% of that savings in bonds, and we expect the stock to return 8% per year and the bond to return 4% per year. So, like I already said, from ages 22 to 65 will be 43 years, 30% of that $65,000 at year's end, and so on, because his salary will be increasing by 3%. So 30% of his income every year end will be saved into a savings account or invested. 2% inflation per year, 5% interest per year. 60% of his savings will go into stocks, 40% will go into bonds, and the stock return will be 8% per year, while the bond return will be 4% per year. So those are the key details we need to keep in mind while we're looking at the situation. So some of the problems we are looking to solve here, or to learn more about, gain some insight, will be the total amount of savings he'll have at age 65, the present value of that investment, because we know that the dollar today is worth more than the dollar in the future due to the time value of money. And then we'll choose an alternative plan or make up a possible alternative plan that could potentially be better as an investment. And then if he was to invest $1,000 more at the end of each year, how would that alter his plan? So for the R and driver, I had Google Gemini help me model out a timeline in 10-year bins or snapshots that shows if he invests 60% in stocks, 40% in bonds, what will the return be every year. So in the first year he invests $65,000, which is his salary. 30% of that will be $19,500, so the savings will just be $19,500 at 0.0. Then 10 years later, 3% increase in his salary every year, which at that rate, his salary will be $87,343, and then 30% of that is $26,203. And by this point, we'll already be at $395,000 in 10-year time, in 10-year times value of money as well. And then year 20, the salary gone up another 30%, 3% each year. So that means we have more money to invest into our savings account, and at 20 years we'll already be in the million mark. Then 10 years after that, you can see that it's just growing at an exponential rate, and so on, to our final projected total savings of $6 million. So this is a little model of our timeline to really see how the growth will be exponential with all of these factors increasing. So then, for the I in driver, I had Google Gemini help me create some Python code using the pandas libraries to calculate all of the financial points we wanted to gain some more insight about, including that same value of the total amount that he will earn with 60% going into stocks, 40% going into bonds, that $6.2 million mark. And then, as we can see, we also calculated the present value of this amount, which will be $762,000, which we can see up here with this equation, the future value divided by 1 plus the interest rate raised to the years. So I'll run this code real quick just to show that it works. So yeah, we can see that up here, the $6 million mark will be the amount earned with that first plan, present value of that value being $762,000. Now I plugged this into a financial calculator to compare that with another source and validate my results for the V and driver. And we can see here that $727,000 will be the present value given that total, the number of periods, 43 years, 5% per period, compounding. Yeah, I don't know if I did that right because that's times per period, 12 times per period for each month. So doing with those calculations, it'll still be in the $700,000 mark, which is $40,000 off of this value, but still pretty close, pretty realistic to what we can expect the present value of that investment in 43 years to be in terms of today's value. So also an alternate plan for that, 80% stocks, 20% bonds, as generated by Gemini, shows that the total amount would be a lot higher in that plan. In that amount, it would be almost $1.3 million more, which we calculated. We calculated that in here somewhere. Yeah, right over here. So that same information helped to generate this number. So this shows that this plan would not be the very best plan to take, that you could earn a lot more investing more in stocks and less in bonds, even though this could be really risky. And it's smart to really diversify your money all over the place. But if you're willing to take the risk and all else stays constant, then it shows that this plan could provide more value to you, earning you almost $1.3 million more. And then if you use the original plan, adding $1,000 extra into your annual savings through this code right here that we generated in Python, the total amount will be almost $200,000 more. So that makes sense because you're adding $1,000 more over 43 years. So that being almost $200,000 more makes lots of sense, especially with interest compounding for you. So like we said, we already touched on calculating the present value, comparing that to a financial calculator. Now, some more complex applications of this could be analyzing a financial plan with more parts involved, like if you account for more taxes that you have to pay for, or other higher interest, or many other different stats that you have to really account for while you're making a financial plan. And things can change often, like taxes could increase on you, decrease. So it really all you can use this same method to really account for all of that. It can also be used to model career changes or drastic increases in earnings. Same with decreases. Like if you got a different job that gets you a salary of almost $500,000, or if you start a business and it goes crazy and you earn lots of money, then you can use this same calculator to calculate a different plan to save and invest your money. Then it can also account for large purchases like a car or a house and how that could change the goal. And then some surprises I learned while doing this. Over time, money grows a lot more than you think it does, especially with compounding. And it really makes sense to, start investing early so that you can take advantage of benefits of compounding interest. So it can grow and double every year or over years' time. And like as we saw with this example, investing right at 22, right out of college. I'm 21 years old. If I start investing now and this followed the same plan, I could grow an investment of, say, $5,000 to multiple millions of dollars towards when I want to retire. So it's really just interesting and surprising to see how much the money you invest can grow with compounding interest. Although it still will be less in the future compared to today's value using the time value of money principle. So that is my assignment. Thank you for watching, and I will see you in class.